Hi everyone, Assalamualaikum. In this video, we will continue with applications of the chain rule, which is rate of change. Okay, now we look at example 6 from previous semester papers. The height h of a right circular cone is decreasing at the rate of 3 mm per second, while the radius r of the base is increasing at the rate of 2 mm per second. How fast is the volume V changing when the height and the radius are 100 mm and 50 mm respectively? Alright, to solve this problem, step 1, we need to write down all the information. Okay. From the height h of a right circular cone is decreasing at the rate of 3 mm per second, we can write the height dh over d time because rate here and because over second here. So we can write d height or dh over d time equals to, the word used here is decreasing. So we need to put negative sign here and then 3 mm per second. Okay. And then the radius r of the base is increasing at the rate of 2 mm per second. So we can write d radius or dr, and then the word rate here means over d time, or over second here means over d time. Okay, and then the word used here is increasing, means positive. Okay, and then 2 mm per second. Alright, and then how fast is the volume? Okay, volume means dv. Okay, fast here, how fast means the rate, means based on time. Okay, and then how we want to find, so we put equals to question mark. Okay, when the height and the radius are 100 mm and 50 mm respectively, means height equals to 100 mm and radius equals to 50 mm. Alright, now we done write down all the information here. Okay, after that we can continue with step 2. Find del V over del H and del V over del R and its value. Right? Alright, from the volume of cone, V equals to pi over 3 R squared H. So from here we have variable R and H. That's why we need to find del V over del H and del V over del R. Okay. Alright, to find del V over del H, we need to differentiate from V. Okay. And del V over del H means partial derivative of V with respect to H. We treat H as a variable and at the same time we treat R as a constant. So to avoid error and easy to differentiate, we can write H at the back and we write in different colors. And R here means constant. So R squared also constant times pi over 3 is also constant. Okay. And then to differentiate constant times H, we can imagine, let's say we want to differentiate 2 means constant, 2H with respect to H. Okay. So the answer equals to 2. Okay. Means that when we differentiate constant H, the answer equals to constant. Okay. So same goes here. When we differentiate constant H, the answer equals to constant, which is pi over 3 R squared. Alright. And after that, we can substitute the value of R. Okay, R equals to 50 mm. So we replace here. Then we simplify, so we get 2500 pi over 3. This is the value of del V over del H. Okay, when H equals to 100 mm and R equals to 50 mm. Alright, after that, we need to find del V over del R. We differentiate from V, okay, equals to pi over 3 h r squared. Alright, del v over del r means partial derivative of v with respect to r. We treat r as a variable and at the same time we treat h as a constant. Alright, so h here is a constant, so time pi over 3 is also constant. And to avoid error and easy to differentiate, we can write variable r at the back and we write in different colors. Okay. Then when we differentiate constant r squared, we can imagine, let's say we want to differentiate constant r squared. Now our constant equals to 3. Okay. We already know the answer equals to 6r. But how we get 6r? Okay, before we get 6r, actually we just put constant in front here. We keep the constant in front. Then we differentiate r squared. So we get 2r. Okay, we differentiate with respect to r here. Okay, so after we have 3 times 2r, then we simplify, so we get 6r here. Okay. And then same goes to constant r squared. When we differentiate constant r squared, we can refer from here. Okay, we have constant, okay, which is pi over 3h, and then times 2r here. Alright. Then when we simplify, we get 2 pi over 3rh. After that, we substitute r equals to 50 and h equals to 100. Okay, then we get 10,000 pi over 3. Now we done find del v over del r and its value, and we done find del v over del h and its value. Alright. Alright, from the previous slide, we done step 1, write down all the information, and then we done step 2, find del v over del h and del v over del r and its value. So we get this. Okay. Now we can continue with step 3, set up the chain rule formula. Alright. Okay, from here, we want to find dv over dt. Okay. And v related with two variables, which is r and h. If there are two variables, the chain rule will have two pairs multiplication of derivative. Okay, between two pairs of derivative is a plus sign. Alright, so the first numerator should be del v. Okay, and v here related with r and h. So we can write here. Okay, we can write this. dh and del h, dr and del r. Okay, we just imagine, let's say we can simplify dh and del h, dr and del r. So we get back del v over dt plus del v over dt, and it's equals to dv over dt. Alright. And then from here, del v over del h equals to 2500 pi over 3. Okay. And then dh over dt equals to negative 3 mm per second. And then del v over del r equals to 10,000 pi over 3. And dr over dt equals to 2 mm per second. Right? Okay, after that, we can simplify. We can multiply here. So we get, from here, we get negative 2500 pi. Okay, because we can simplify 3 and 3 here. And then plus 20,000 pi over 3. Then we simplify, so we get dv over d time equals to 12,500 over 3 pi. And then from here we have volume. So volume means mm cube. And then over time here means over second. Alright. So our dV over dt equals to positive 12,500 pi over 3 mm cube per second. Okay. From here, this means the volume is changing at a rate of 12,500 over 3 pi mm cube per second. Alright. Coming up next, partial derivative for implicit functions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.